Today we're going to be talking about electrical circuits. We've already touched base on what an electrical circuit is, however, we didn't talk about the different kinds. As a recap, an electrical circuit is a connection between the negative portion of the power source to the positive, and this will help us to power and use electrical devices. A series circuit is one kind of electrical circuit that we're going to learn about. It is a closed-loop path for electron flow. You don't need to write this, but I just wanted to show you an example of a series circuit. You have seen it, I just didn't tell you that that's what you were looking at. This is an example where the battery source here and the negative portion is connected by a wire into the two light bulbs that is then closed up at the top with the power source at the positive side. The schematic diagram is over here on the right, showing the two light bulbs and then the negative and the positive side connected with the wire. Here's a question for you. Think about it and then check your answer. What would happen if the circuit were disconnected anywhere along the wire? It can be closed here, how about here, or just anywhere along this wire. Pretty much what would happen is that this circuit would not work. You would have electron flow from the negative portion and it would stop and it can't go over because it's not working. If it's disconnected, the electrons cannot travel through to the other side, and if it can't travel through to the other side, then you have no electrons going through the two devices here, which are the light bulbs. Here's another example. What if one of the light bulbs was not working? What would happen in this case? If you said that neither or this other light bulb would not work, you are correct. And the reason being is that the filament would be the pathway that the electrons would travel through in order to get to the other side. If this part of the circuit is not working, then the electrons cannot go through, therefore it cannot get to the next light bulb, and inevitably it would not be able to get to the end where the battery source is. Here is the same series circuit. What if you were to add more light bulbs to this circuit? What would happen? Let's say we put the light bulb here, or we put it over here on the other side. Doesn't really matter. Let's just put an extra light bulb. By adding an extra light bulb, you're technically adding more resistors because remember, the electrons need to go through each of these devices, and by doing so, it's actually bumping into each other, therefore creating the light. So with more resistance, your current is going to decrease, therefore the brightness of each light bulb will also decrease. This was the bane of my Christmases when I was younger. We don't have this problem now, thankfully. However, what this looks like is this is a series circuit, and we have the electrons that would go into each of the light bulbs of the strand of Christmas lights that you would put on your tree. And as it would go through, then the electrons would go into each of the filaments, which would then light the bulb. Works out perfectly as long as each bulb is perfect. If one of these bulbs went out, you would not know which bulb went out because all of the lights would not work. And so we would have to unscrew one light bulb and put in a good one and see if it lit, and if it didn't, you'd put the other one back and you'd have to do it for the entire strand. It was a nightmare. Thankfully, technology has improved so that if one light bulb goes out, we don't have that issue. We know exactly which light bulb goes out that we can replace, and we can have our Christmas lights. A parallel circuit is the second kind of circuit. It is, again, a closed circuit. However, it has multiple paths for electron flow. The more resistors that you add to this kind of circuit, the current for each path is equal to each other. The overall current is the sum of each parallel current because the resistance decreases. The electrons flow on multiple paths. Here is an example where we have two light bulbs that are connected to two different wires, and they are on different loops. They are all connected, however, because the power source is here, we have electrons that are able to go into the first light bulb and go back to the positive side, or the electrons can actually go through to the second light bulb and back through to the positive side of the power source. The nice thing is that the electrons have a choice, and so they equally disperse into each of these loops, and therefore you have the same amount of brightness, you have the same amount of current going through each of the loops. This is the schematic diagram for this picture here, and we have the light bulbs here, and we have the connection via the wires, and we have the power source with the negative and the positive sides. Now, what would happen in a parallel circuit if you added more light bulbs in a parallel fashion? So let's say we added another bit of wire here with another light bulb. Because they are in series, the electrons are able to flow equally into each loop within the circuit. You would actually have the bulbs being the same brightness. The total current would be the sum of each individual current. So let's say we had 20 amps going through here and 20 amps going through here. Your total current would be 20 plus 20. If I had a third, and let's say that's 20 also, then that would be 20, 40, 60 amps would be my total current for this entire circuit. All right, so this was a short set of TNOTES. Be ready to apply this in class and have a great day.